Good morning. It's Saturday, May 2nd, and welcome to the Doctors In Ask Dr. Arwady. I'm Sybil Madison, your Deputy Mayor for Education and Human Services. I'm here with Alison Arwady, your Commissioner for the Chicago Department of Public Health. See what happens when you take a day off from the show.
Yep.
Thank you for joining us. We're here to answer your questions, give you the latest updates on COVID-19. If you have any questions or comments, you can put them in the box below. You can also send them using the hashtag AskDrArwady through Facebook or Twitter. We always start off by checking our social distance. It looks like we're good. And that's just a good reminder to you, too, that if you're an essential worker, to still keep your social distance at work. If you're doing essential tasks like going to the grocery or to the bank, please be aware of your distance and keep that social distance with others. And if you're in a place where you can't keep that social distance, it's a good idea to wear a cloth face covering to keep others protected as well as yourself. So, Dr. Arwady, where shall we begin?
All right, let's do a data update. So as always, you can go to chicago.gov/coronavirus. Right up at the top, you'll see a tab that says latest data and reports. As of today, we're at 22,744 lab-confirmed cases of COVID-19 here in Chicago and 962 deaths. We had an increase of 1,238 cases and 30 deaths since yesterday. Illinois has 56,055 cases and 2,457 deaths. And Illinois actually had the most cases it had reported to date yesterday. So yesterday also, of course, was the extension of the governor's stay-at-home order. And we need people to keep staying home. So we're gonna maybe I'll do some data, and then I think we'll show the dots map again, just to help people understand that.
Doctor, how much is the increase in cases related to the increase in the amount of testing that we're doing?
Yeah, it's a mix. So we talked a little bit about this yesterday. So certainly as we are seeing more cases, more testing, we identify more cases, we diagnose more cases. But it's not just that more cases are being detected by testing, because we also follow things like hospitalizations, ICUs, even deaths. And so we have, as we've been saying every day, we've been making progress in terms of seeing that curve flattening, but we are not seeing it decreasing. So we're not yet seeing it decreasing for the cases. We're not yet seeing it decreasing. You know, we're close there, but there was a reason to extend the stay-at-home order.
Yes.
And I am a little worried because I was out today. I don't know, were you out? It's a beautiful day, and people are out. And if people are out and they are by themselves, or they are only with people in their household and they're being careful and they're keeping their social distance, that's good, that's fine. But I worry, we're seeing more traffic, we're seeing more movement, and you know, we track some of that blue dot data, right? That looks at how much are our devices staying home, and we're not doing as well. We're seeing people as we were before. We're seeing more people out and about. And really, you know, even yesterday we were seeing some of these protests against the stay-at-home order. You know, I'm worried because we need to get on the other side of this curve.
Yes.
And
staying at home has gotten us to the place that we're at.
It's gotten us to this flattening place. But, you know, we're not going to see that peak until sometime in May. And the more we have new infections, the more we have people out and about and not abiding by the stay-at-home order, the longer that peak gets pushed and the longer it takes to actually start being on the other side. So we're making all kinds of plans for reopening and how to do that safely. But the biggest factor in all of this is how many new infections we have. And how many new infections we have is directly caused by how many interactions people are having with each other. And so You know, I'm wearing my spring sweater today. I'm excited for, you know, the warmer weather.
I obviously didn't
the
check the
forecast. Yeah, but you know, and it is lovely to have some nicer weather, and you know, I know what a hard time it is for people. So on that level, I'm glad that there's some sunshine, and I want for people's mental health, it's good for their physical health, but still, you know, we are a long way from being on the down, you know, ready to start backing off on this. And the less people hang in there with us, the longer that sort of may go in terms of being safe. So you can look online if you want to see more of the data. I'll just highlight where we look at our cases. We are really seeing cases across all age ranges. Actually, our most cases have been in the 50 to 59 age group, followed by the 40 to 49 age group, but they're in all ages. Where we just look at cases, we're about 50-50 in terms of men and women. When we look at race ethnicity, Black, non-Latinx Chicagoans are making up about 38% overall of our cases right now. Latinx Chicagoans making up about 35%. So we've seen increases there. Some of that is because there's been more testing, as you say. Some of it is we've been working on trying to improve the reporting of race ethnicity. And some of it is just that there are more cases and more spread in that community right now. So there's work happening related to that.
Yes.
Our cases among white non-Latinx Chicagoans making up about 18% of the cases. Asian non-Latinx around 4%. And then people who report another race or ethnicity or a mix, about 5%. And if we just look at the deaths quickly, you remember I said most of the cases we're seeing in people who are in that sort of 40s to 50s. But where we look at deaths, it is very, very disproportionately still impacting our older people. So we are at 80% of our deaths being in people over 60, even though people over 60 only make up about 18%. So that's 4 in 5 of the deaths in people over 60, where they're less than 1 in 5 of the population. And if you look at people over 70, that's 59% of the deaths. So almost 60%, almost 3 in 5 of the deaths in people over 70, even though people over 70 make up only 8%, less than 1 in 10 of Chicago's population. So we also are continuing to see men die more than women, 62% of the deaths in men and 38% in women. We've talked about that. And where we look at the deaths by race ethnicity, 53% of the deaths still are in the Black non-Latinx community, even though Chicago's population is about 30% Black. 23% in the Latinx community, 18% in white non-Latinx Chicagoans, 5% in Asians, and 1% in other. So, you know, we talk a lot about the race ethnicity work and the
racial equity rapid response team.
Thank you. 93% of our people who have died in Chicago have had these underlying chronic conditions. So let's look at the dots actually a minute, because we haven't done that for a little while. And this again is just a simple way that visually you can see why staying at home really makes a difference. Staying home save lives. So we won't start it just yet, but if people haven't, it's been a little while or you haven't seen this with us before, this is just an idealized population of about 200 people. And first we're going to start with a simulation where all the blue dots are moving. So a blue dot is a person, normal times, who is uninfected. They're all moving around, and then basically there's one person who's infected, and then very quickly it spreads because everybody is moving. So we're going to see people, an individual person, be a blue dot, and then as they become infected, they turn to a red or an orange dot, and then as they recover, they become a purple dot. So let's run that first simulation. And we're going to see everybody just moving around, and you can see really how quickly that infection spreads. And that's consistent with a very steep upward trajectory. That's where you would be seeing your R0 really be very, you know, a big number, a lot of spread quickly, and you would overwhelm your health system really quickly. You'd run out of the ability to care for all of those red dots and have problems. So then in contrast, if we instead take a simulation where 75% of that idealized population is staying home. They don't move, but about 25% of the people have to be out, and they're moving around and having, having the opportunity to have some infection, and we see how that spreads. Again, we're going to see blue dots turn to red or orange as they become infected, and then purple. And go ahead and start it, and you'll see that it's much slower here. So first of all, we have fewer people getting infected overall, so only about 22% of the people here get infected. We're protecting the folks who are not moving, so especially if those are people over 60 or have the underlying conditions, and we don't overwhelm the health system. So we've been behaving more like the second simulation here by and large, where again, where we've talked about some of that cell phone anonymous data that we use, where, you know, we've been in the range where, I mean, when the last time that we'd pulled it, prior to last week, more than 80% of the cell phones, when you check, are sort of at home or within 200 meters of home, and that's been good. But as we're starting to see some of that slip and we start to move backwards, we move from being more like that second simulation, you know, back towards that first simulation. And if we do that, like, this virus is going to take off. Like, there is nothing that has changed about the virus that makes it less likely to spread. And we have got to get in Chicago and Illinois on the other side of this curve, where we're seeing the R naught, sort of how many infections one person is usually, how many people one person is spreading to. We have to get that to where it's below 1, where on average one person is spreading not at all, right? As opposed to one person spreading to 2 people or 3 people, or we've got to get that down, and having fewer interactions. It's sort of the big hammer approach, but when we're on the trajectory we're on, it's what we need to do.
Yeah, so we can't take for granted the fact that we've flattened the curve, and we've got to keep doing the things that we've done to flatten it in order to bend it.
Yeah, and we know it's hard, but we need you to hang in there with us, please.
Yeah, we really do.
Yep.
Yes, we do not want to see a surge.
No.
Yeah, and it can happen.
Yeah.
Right? Okay, let's get to questions. Shaw Bridget McCarthy from Facebook. Remdesivir. Did I say that right?
Remdesivir, yes.
Oh, remdesivir. Is that something that many patients are getting access to in the hospitals in Chicago?
All right, good. So exciting news on remdesivir. We had our first, and it is remdesivir, our first drug get an emergency use authorization yesterday from the FDA, yes. So I talked about this a little bit yesterday because we'd seen some preliminary data, and as expected, the FDA gave this emergency approval, okay, for remdesivir, yes. Now let's talk about it, because it's a treatment for patients who are severely ill, okay? So it's not for everybody, it's for people who are severely ill, and it is not a cure. So what they've seen, we're still waiting to see some of the official data. This was a federal trial from the National Institute of Allergy and Infectious Diseases. That's what Dr. Fauci, who you see standing next to President Trump, he's in charge of that agency. And they had a trial that had more than 1,000 hospitalized patients in it. And basically they found that patients who had gotten remdesivir recovered faster than those who had gotten a placebo or medicine that doesn't have any of the active agents in it. So people who had gotten remdesivir and were critically ill recovered in 11 days, and the others recovered in 15 days. But the drug did not significantly actually reduce fatality rate. So it didn't actually make it less likely that people would die, but it shortened the time for those that did recover. Similarly, there was a trial out of China that showed that remdesivir also did not do a whole lot or anything significant to reduce the mortality rate. So this is a start. This is one of the first drugs that has come through a trial and said, okay, like, for people who are severely ill, this is something to try. This is something to give for people who recover. It helps. And so Gilead is the producer of this, and they've got enough for about 150,000 patients right now. That'll all be available free of charge to those patients. It's not fully approved yet. I want people to sort of understand.
It's got that emergency use.
That emergency approval. Not that dissimilar from what we've been talking about with the antibody testing, right? They have this emergency use authorization. There's been some preliminary data.
Investigation.
It's still under some investigation, but once you get this emergency approval, it means the FDA says this drug has some efficacy. It works to an extent against this. So exciting. Yes.
I'm trying to remember what you've said before about it. Is this a drug that was used with Ebola? Yes.
So they tried it for Ebola. So it's interesting. It's a drug that has been like they tried it for hepatitis, they tried it for Ebola, and it had not shown a whole lot of efficacy, but it's one of the ones that was suggesting that it at least has some promise, and the FDA has now said, yeah, it has some promise. So that's exciting. That's the first sort of actual treatment that's gotten some approval.
So who's going to have access to this under these EUA?
Yeah, exactly, through the emergency approval.
Yeah.
So patients here in Chicago have already been getting remdesivir. So we had people at a lot of our hospitals, both as part of this trial and other trials. It's not like there's just one trial of remdesivir, but also there's something called compassionate use for even people who are not in the trial. They've been able to get it. So people who have been seriously ill, in ICUs especially, or even just needing to be hospitalized, access it through the doctors in the hospital. And this is big news, obviously, in the treating community. So I sort of watch the research and the conversation among the doctors who are taking care of patients at the same time as we're watching the public health. Just maybe we'll do a quick update of where some of these other trials are, if people are interested. So in addition to the vaccine trials, which are a whole kind of other world, and there's at least 85 or maybe even 100 different vaccine trials that are sort of at different stages of in the lab, in the early pieces, that's going on. But some of the types of drugs that are being studied, okay? So remdesivir is one that's in what's called an antiviral. So it is a medication that is specifically trying to block the way viruses can replicate or copy themselves, okay? So this is where remdesivir has this early promise. There's at least 17 trials going on just of remdesivir, okay?
Got it.
Then this is where...
So does that mean that the virus is copying itself inside?
That is exactly what it means.
And so is that why the recovery is shorter, because it's stopping?
Perhaps. Yeah, exactly. Exactly. Okay. Yeah, if you really... So remdesivir, how it actually sort of works is that so the novel coronavirus is an RNA virus, and that matters because RNA viruses are the whole job of a virus is to copy itself. It gets into your body and it sort of hijacks a cell and it starts churning out millions of copies of itself. That is actually how it does. And when it is an RNA virus, RNA does not have the same proofreading ability that DNA does. So when it's making millions of copies of itself, it will make mistakes. That's actually a mutation. So we could talk about that. And it can't fix itself as well as DNA can. And so it means that RNA viruses can actually mutate more. And that's why flu viruses, like influenza, part of why we need a flu vaccine every year is that it's an RNA virus that mutates a lot and changes so much that you need to adjust your virus. But this one, the way the antiviral like remdesivir works is it actually gets in and it kind of messes with the way that the RNA would be replicating, and so it stops the chain actually of the RNA. It jams the copier. Exactly. That's exactly what it does. Very good. That's a good analogy. And so yes, it blocks this replication machinery. So they've been studying some other antivirals too. So there are some medications that are used for other viruses like HIV and others. Lopinavir is one with ritonavir that we'll sometimes use in HIV. That some of the way that this virus copies itself can be somewhat similar. So they've been studying, obviously in labs first, but then in humans to see without having other effects, can you get at that sort of copying mechanism? Yes. So that's antivirals. Another big class are anti-inflammatories. So those are, remember we've talked a little bit about this cytokine storm is the term that when people get really sick with a virus, their whole immune system kind of kicks into overdrive. And you want your immune system to respond, but if it responds too much, literally this term is called cytokine storm, and all of these inflammatory agents sort of do a number on the rest of your body. So they start messing up your kidneys and your liver, and they can cause problems with circulation, and you kind of need your immune system to tamp down a little bit. So they've been working on there's some drugs, there's about 50 or even more trials that are going on with different anti-inflammatories, again, for people who are seriously ill about that. There's the convalescent plasma that we've talked about, right? So that's when you take people who have recovered from COVID, and you actually take the sera, you take the plasma from their blood, not the red blood cells, white blood cells, or platelets, but the other kind of liquid material that has these antibodies that, because they've recovered, their immune system has produced some antibodies, and you then transfer those antibodies to somebody who's very sick and fighting. So there's 57 trials that are going on using plasma donations to sort of see how that works. And then we've, the president has been very excited about these anti-malarials, right? And the anti-malarials we're interested in because there's a thought there. If you look at how the drugs work, it might help block the virus from sort of getting into cells. And so that's like the hydroxychloroquine. There's 142 trials going on looking at that. Chloroquine, there's 21 trials going on looking at that. And the idea is, these are just some of the classes, but you sort of go at this virus in different ways. You go at the way it gets into the cell. You go at the way it copies. You go at the actual antibodies themselves. You work on the response. And these trials, as they come out, they help us know, first of all, what works. So remember, we talked about some of these there's a reason that hydroxychloroquine has not yet been there's not been a trial. There's not been the FDA saying emergency use for it, because where there have been some trials, we've seen some really bad effects. They've had to stop. They'll stop trials early, either because something's working really well or there's really serious side effects. And so, there were a number of these trials where people were getting these medications and having really bad heart rhythms and actually dying from that. So you can't, that's no good. So anyway, hundreds of trials going on, researchers around the world, including here in Chicago, working on them, and we'll keep you up to date as we make progress. But that was exciting.
But really promising news.
Really exciting, definitely.
Yeah. Okay. At MashyTT from Twitter. Two questions.
Okay.
So, question one. As we are slowly transitioning into the summer season, should we expect the number of cases presenting with flu-like symptoms to change? No. So the symptomatology, I do not expect that to change. So this virus, in a lot of ways, looks like flu. It comes most typically with fever, cough, shortness of breath. Those have been the top three from the beginning. They're still the top three, even as we continue to learn about all the other things that can come along with that. But that fever, cough that looks like influenza, we have no reason to expect that the presentation of that would change. If we saw any seasonal change to this, it wouldn't change the presentation of it. So we follow, actually, influenza-like illness. That's one of the things that we track all the time anyway in emergency departments around Chicago. So it gives us a sense during flu season of what to expect and how are we doing. And we've been using some of that same data. It's actually, if you look at our daily update on the bottom here, this actually is our syndromic surveillance. We could talk about that another day maybe, where we look to see, we've started to see some decrease in the influenza-like illness that has been presenting recently, especially among younger people. It's still up among older people. It's a way of us, in this syndromic way, following whether people are coming in, whether it's flu or COVID. We just call it influenza-like illness. You could also call it COVID-like illness. But yeah, we would not expect the symptomology to change. Okay. Question two. How do you expect the current percentage of COVID-19 positivity, which 29 to 30%.
Very good, right?
Hey, MashyTT, you've been looking at the data. How would you expect the current percentage of COVID-19 positivity to change as we transition into the summer? So another seasonal question.
Yeah, another good question. So that positivity is going to come down because, not that it's summer, we are going to have more testing. So we absolutely want to push that number down. It's one of our actual primary goals as we are following the outbreak here, because, and we'll probably set some different goals. I'm giving you a little preview into some of what we're thinking about here, but there's both the testing that public health helps drive through partners in congregate settings. So the testing that we're doing in homeless shelters, especially in long-term care facilities, that we'll do even in a workplace kind of outbreak, where we have reason to expect that disease is spreading.
And that there's been a high exposure.
And there's been a high exposure, and we're doing sort of some focused testing in those settings. Those congregate or sort of public health testing, we actually would expect, and in many ways want, a higher positivity there, because it means that we're driving testing appropriately to those outbreaks. So maybe, for example, we'll want to drive the app from 30% down to 15 or 20% maybe. But in the general population, 30% tells us that there's still quite a lot of COVID out there. We know that still not everybody is getting tested, but as we increase more testing, following that percent positivity gives us a good sense over time of what the cases are looking like. You can either have that there's two ways for that percent positivity to come down. Number one, you have fewer cases, so that will happen as we are on the other side of the curve. And number two, you have more testing, so that will also happen as we drive up the testing. So naturally, those two will come together. And I want us to get to a point where, especially in the general population, we're down to more like 10%, right? Or 15%, 10%, really be seeing that come down as both our cases come down and our testing numbers go up. So again, that doesn't really have anything specifically to do with summer. It's just that both of these things will happen as the summer comes in. And again, will we see some of that seasonality? We may, but I don't think it's going to be the biggest part of this.
Okay, all right. Here's somebody else who's been paying attention to what we're talking about. At QTB, how much is the virus mutating? And is that a problem with the vaccine?
Oh, good question. Good question.
We were talking about the copying.
We were. Okay, great. So I love this question. Well, let's no. It's good. It's really important. And if people understand this, you actually understand a lot about the virus, the vaccine. So I love it. All right. So we just said it's an RNA fingerprint. Or it's an RNA virus. And there's sort of this fingerprint within RNA. If you think back, if you had high school biology, you probably learned about, ACGT, right? Like that's DNA, and RNA just has a U instead of a T. But the idea is you have all of these little letters, little genes that line up. And so for coronavirus, there's about 30,000 letters if you were going to spell out the genome. And so literally you could be like, this genome is ACGU.
It's like pi.
Right. It's like what?
It's like pi.
Pi? Oh, yes, right. But the idea is that you've got about 30,000 of these letters, and then these letters, to bring you back to high school biology, 3 letters make an amino acid, and then a bunch of amino acids, like hundreds or thousands, make a protein. And then the proteins make more virus. Okay? Don't worry. That's
Samara, are you listening? That's my daughter.
All right,
this is she better be watching right now.
So the point is, we just said that RNA, the whole job, the virus gets into the cell, takes over the cell to make millions of copies of itself.
Yes.
And because it doesn't have the correcting mechanism like DNA does, it makes mistakes when it copies itself. And so you've got 30,000 ACGU, and then maybe after it copies itself a whole bunch of times, like a U might become an A or something. Like you actually have a change in that letter. And it doesn't matter that much if you change one letter, because especially if it's the third letter, it might not even impact the amino acid that's made, and then the amino acid might not impact the protein. But the mutations are the way that scientists can actually track how this disease spreads, like over time and across people. So
why?
So the first genome was done for this back in December in China, was published internationally, and you sort of had a starting place. You had a 30,000 alphabet of a starting place for the virus. And then they've been sequencing viruses over time. So there's been like 4,000 individual patients who all have novel coronavirus, but you run you check their genome and you see how many little letters have changed, how many those are mutations, how many of those have you seen? And then you can use that, first of all, to see how it has spread. So for example, if it's in where it was sort of replicating a lot in China, you ended up with a few slightly different versions in like different parts of China. And then it got to Europe and there were some slightly different ones here. And then there's a slightly different. The slightly difference is not in the way that the coronavirus behaves, but in the genome itself. And so we could say early on, for example, where we had like some of those early cases out in Washington, you could look at that genome and say, oh, this is an exact match of the genome that we were seeing from Wuhan. But then later, like in New York, most of theirs were actually more similar to what we were seeing from Europe, for example. And you can compare, like this is something that we do. It's like this newer field of epidemiology. We do it for foodborne outbreaks actually during normal time. And you can sort of look at for food, it's more often the DNA fingerprint, but you can look and say, I know not just that somebody has this bacteria or this virus, but I know the genetic makeup of it, and I can compare the genetic makeup of like someone who has E. coli in Chicago and someone who has E. coli in Colorado, and if the mutations in that are the same, I know that they got it the same way. And so that's how you know it's more of like a national distribution as opposed to like a local outbreak of like, around a restaurant. So, so for this purpose, the point is that, first of all, it lets us know how quickly is this mutating is important because first, it lets us just understand how viruses spread, how long it's been there. You might have remembered, like in Seattle, for example, part of the reason they said, oh, we know that there's actually been virus here for at least 5 weeks earlier than they had thought was because there were some new mutations that they were able to see. And so they knew it wasn't just a new introduction of the one from China. There were some new mutations, and they've learned sort of how quickly it helps you track. So how quickly these mutations come in help you know how much is spreading. And the good news is that novel coronavirus is not mutating very fast compared to many other RNA viruses, even to some of the other coronaviruses. Most genomes, and again, they've sequenced something like 4,000 of them. Most have like 10 or fewer little alphabet changes, ACGU. That's very few. And only a small number even have more than 20 of them, okay? And even if you had like 20 of those changes, that's still much less than even like 1/10 of 1%.
Think about how there are 3 million people across the world, right, who have contracted the virus. So that's not a lot compared to the number of people. It's not a lot in terms
of how fast, and RNA, as soon as, like, we worry more about RNA viruses, like I said, like influenza, right? It mutates very, very quickly, and it's why we need a new vaccine every year. So it's good news that the mutation rate of this has been slow. The mutation rate is also important because we don't have drugs that have gone up against this. The virus has been extremely successful in spreading. It's not had a lot of like external pressure to mutate, if that makes sense. And so the good news is that because it is slowing, it is a very slow mutation. It's like mutating over years instead of over days or weeks like we see for some other things. The good news is that as people have some immunity, or especially once a vaccine gets developed, we're more likely to like actually be able to make a pretty successful vaccine, and hopefully that vaccine would sort of last on the order of years as opposed to on the order of of months, or even we do flu every year because it has mutated so much sort of in that last year, and there are all these different strains. Once you have like a lot of mutations, that's when you start to have actual different strains of virus that can behave in different ways. And so we've not seen any new strains. This has been reassuring by and large from a mutation standpoint. Which is good for the way it can spread, but it's also really good where you think about vaccine. And the last thing I'll say is that one of the most interesting parts of research here, like we were talking about how the drugs will impact, they go after how does the virus get into the cell or how does it replicate. But you can actually look and you see where in the genome have we seen the most mutations. So if you see a whole lot of mutations kind of over in this part of the fingerprint, it tells you that the virus can tolerate mutations there pretty easily. Like it doesn't bother the virus to have mutations here. But you can find parts of the genome that like we've not seen any mutations in yet, and that tells us that the virus probably can't tolerate mutations there very well. Like if a mutation comes there, basically it can't replicate, it dies, it doesn't go on. And so some of the most interesting, like genetically focused targeted work of the researchers is to say, what can we do to sort of come up with a drug or a treatment that works on that part of the genome? Like, what does that part of the genome encode for? Is that a particular protein? Is that something about how the virus gets into the cell? Like, it starts to give you a clue that that's a good point to sort of build a drug around. So that's how they've made all these really successful HIV drugs. Like, this is the work of sort of taking the genome, you look at these mutations, and then you say, okay, here's how we use it for vaccine, here's how you use it for drugs. So
it's like forensics.
It's like forensics, yeah. I mean, this is like epidemiology, public health, you know, the science of vaccines. It's great stuff.
Okay. Yeah. Maybe there's going to be a COVID show on TV after all this
is
over.
The COVID show. This is all we got. So, yeah, I mean, it's, you know, this is such a terrible, terrible time for our city in so many ways. And, you know, every day, you know, I'm reading these death numbers and I'm hearing from folks, you know, my team is talking to the families that are just experiencing such terrible things. We're seeing just the huge economic impact, the social impact. I mean, it's such a terrible time. But the sort of science itself has been pretty amazing in terms of how quickly it's moving and the collaborative effort that we've seen.
All over the world, people are working on this.
Everybody is sharing, and actually the CDC that just announced this last week, like they've put some things in place to make sure that as some of this kind of research is being done, it's all publicly available, it's shared. In the same way that like our hospitals that at baseline might be a little more competitive with each other, researchers also are really sharing information and being very collaborative because there's such a recognition that we need this like for everything, like to be able to get our economy going again, to get on the other side of this curve. And you think about the US is one thing, but you think about this spreading through, you know, I've done a lot of international work, including in settings where, you know, there are whole countries that have 10 ventilators, 20 ventilators in the country, right? Like, you know, here in Chicago, you know, we worry when we get below a few hundred of excess ventilators, and just the potential for sort of spread and major impact that goes well beyond the economic pieces. You know, you think about sort of at the world level, people who have we've made a lot of progress against poverty at the worldwide level. This really has the potential to push that way backwards. So, I mean, I'm excited about the science because it's progress, but there's a reason that it's moving as fast as it is.
Yeah, because we need it to.
We need it to.
Okay, Heather Don Yeager from Facebook. If we got a test at a FEMA site, and it's been 7 days, and the health department doesn't have the results, is there someone we can contact?
Yeah. So the health department does not have the results of those. So thank you for asking that. The testing sites that were set up by FEMA run independently. They have to kind of report results in, but we don't get them before you get them. The first person that results are reported to are to the doctor who ordered the test and the patient who had the test, and then they get reported to public health. So we know there have been delays, particularly with some of those FEMA pop-up sites. We've been working on the back end to try to help with the reporting, but all I can say is be patient. I know there was a number that was given related to being able to call. Results should be coming, but Chicago Department of Public Health did not have any role in setting those up. We definitely don't receive results, and frankly, we are not very interested in supporting testing platforms that are taking that amount of time for it to come back. So where we're really trying to kind of push testing, we're pushing the kind of testing that comes back. You know, ideally we want to get to a point where it's really within 24 hours all the time. But in our clinical settings, in most settings in Chicago here, not counting those sort of pop-up FEMA things, and some of those were, they're a little longer ago too, so I think they've gotten better. But we're seeing tests come back now really much, much, much faster faster, and we'll continue to say that. So I'm sorry if you're still waiting. I don't have an answer for you. The results should come, but please know that the work that CDPH is doing is really working to help make sure that that our testing turnaround time is quick and that results are getting back. But don't call CDPH. People often call CDPH wanting a test result. The health department does not do testing. We coordinate it. We help make sure it happens. We fund it. There's pieces that we do, but we do not have a laboratory at all. And so results need to come through your original provider. That's another good reason we're really trying to push in Chicago here. The most ideal is we want you to be getting your testing through your doctor. And if you don't have a doctor, get you hooked up to a doctor and have that testing be part of your regular clinical interaction. And so
because there's so much to talk about.
There's so much to talk about.
If you get a positive result.
That's right.
So you really want to be able to talk about that with your doctor or with a medical professional.
That's right. To understand, what do you need to do for isolation and quarantine? And yes, we've built our Tri-COVID coach to sort of help with that, but we want this ideally. And say you have underlying conditions, what does that mean? Having this testing be part of clinical care, we think is really a best practice here. And so we've seen clinics, and we've been helping support clinics stand up, drive through or walk up vaccination sort of next to their clinics. And that we're excited about, helping think about even the hospitals, how can they do that some more? But we think as opposed to sort of the FEMA approach of just standing up a testing site where there's not a lot of follow-up. You don't have anybody to call. That's frustrating. What happened? We really are trying to do this here in a way that that gets, when you get a test result, it also comes with the ability to have some understanding of what to do with that, and you're linked into clinical care. So it's part of our long-term strategy here, especially in the outpatient setting.
Yeah. Okay. Maybe time for one last question. Yep. This is also a data-related question, so it's been
a science day.
It's been a science day, a science Saturday. Face state, it seems there are less dots on the mortality map than deaths. Does each dot represent more than one death?
Yeah, we get that question a lot. They are all on there, I promise. If you take out your magnifying glass and you start counting. So this is, I presume you mean the dot mortality map, where we update 3 times a week the map that shows by geography cases, and we show the race ethnicity of the cases on that same dot. So often we might have multiple cases at one address. We might have clusters, and so sometimes they can look like they're on top of each other, but they are all on there. One dot does represent one person.
Okay.
Yep.
All right, so I think we just have a couple of minutes for some good news.
Yes.
I want to remind folks that tomorrow on the Mayor Lightfoot's Facebook, there's going to be the Sunday Arts Takeover as usual with lots of live music, which we hope that you will check that out.
Let's do, so first I'll let you know we are off tomorrow,
yes.
But on Monday we do have a special guest. We have the Chicago Department of Transportation Commissioner, Gia Biaggi, who's going to be talking about coronavirus and sort of how it is related to streets and transportation and all sorts of good things. So that should be a different angle. I will encourage you, if you have not yet, to fill out your census. We've heard some nice reports of the way people have been using cars and going around and really encouraging people to do this. As a city, only 47% of us have filled out our census. And there are some neighborhoods where we're at less than 30%. And we need everybody to fill out the census. This is how Chicago gets represented at the federal level. This is how Chicago gets federal funding. And boy, is it clear to me that we need federal funding. As the health department, obviously, this is how our population impacts how much funding we get for things like coronavirus response. But that is true across many, many different areas. And so
make yourself count.
Make yourself count.
So
everybody.
That Chicago counts.
So that Chicago counts. Doesn't matter your documentation status. It doesn't matter whether, should I fill it out? Yes. One household, you need one filled out for every single household. So please, check your mail. If you've got a big pile of mail you haven't gone through, you got something in the mail about that. There's ways to do it by phone. There's ways to do it online. It literally takes 5 minutes. Yeah. So, and there was a nice thing here. Navy Pier every Thursday evening in May, and I think they started last night. 2 nights ago. No, that wasn't May yet. So they'll be starting this coming Thursday, next Thursday. Every Thursday evening in May, they're going to be doing a Facebook Live of the Chicago sunset. Isn't that nice? They're going to be using shoreline sightseeing and sort of somehow out on the boat, and here's the sunset, and they're going to have a themed light show on the Centennial Wheel, and they're sort of, recognizing that, we really like our sunsets over the lake, and as it's getting warmer, Navy Pier is often a place that people look to. So those will be on Thursday night, something to look forward to. And then let's end with a nice feel-good picture. People may have seen this, but if not, even Chicago's iconic lions in front of the Art Institute of Chicago know that you have to follow the guidance.
Do they have a face?
They have a face covering. So if you cannot practice social distancing, if you're out within 6 feet, if you're going to be in a store, as of May 1st here, it got added into the stay-at-home order. You need to be wearing that face covering. So we've got that picture of the lion up, and if the lions can do it, and the Picasso statue has one up too, you can do it.
Yeah. And if you're at home and you're experiencing any kind of symptoms, you should keep that face covering on in the home.
That's right.
To protect the other folks that you live with.
That's right.
So we've got a beautiful day, beautiful weather, but Chicago, we still really need you to hang in there with us through this month of May. This is the month where we need to bend that curve. So we hope that despite the gorgeous weather, you remember to stay home
and save lives.